This is just a quick explanation of some of the skills that we've listed on your assessment task notification. The following skills, grid and area reference, scale and distance, transect and bearings, and direction, all skills that we look at when we're using a topographic map. So we'll go into the features of a topographic map. With a topographic map, there are a few features that we can have a look at. The first is the actual grid. So when we look at a topographic map, the grid is always going to be exactly the same. So that's the first thing we can always rely on with a topographic map. The next thing is the eastings and northings. So you'll note that to the bottom here, the numbers go in an easterly direction. All right, so 31, 32, 33. So these numbers are actually referred to as eastings. And then the numbers that go up the side, these numbers are referred to as northings. All right, we'll get into that next, but when we're working things out, it's important to know that. The reason why that is because in geography, most things can be put down to alphabetical order. So that we know the order that we can actually look for things. So if we look alphabetically, eastings comes before northings alphabetically. So we know that we're going to look for the eastings before we look for the northings. The next thing we're going to, I want you to pay attention to is the contour interval. So the contour interval, sometimes it's written on the map, so go for a look for it. But on this map, it is it's 50 meters. So what that means in relation to this particular map is the fact that these numbers here, they are all going up and down by 50 meters. All right, so as you can see, 400, 350. All right, so these are all going up and down by 50 meters. So sometimes a question will ask you for the contour interval, but it hasn't written it for you, made it really obvious. So you have to do the maths. What are the numbers going up and down by on this map? Now these numbers to the side, they are height above sea level. Okay, sea level, and they're always in meters. If you were in a country that did empirical measures, then they would be in feet, but we're not, so they're always in meters. The scale, it's going to be written in a few ways. We'll get to that as well. So here it's been written out for you in words. 1 centimeter equals 500 meters, so we'll get into that. The contour lines are these ones here. So contour lines join places of the same altitude or height above sea level. You will never see a contour line touch another contour line. All right, if they're crossing over something, it's going to be a man-made man-made feature, such as the railway tracks, or they might cross over a river or a creek. All right, but they don't touch. The thing about contour lines is the closer they are together, so up here, the steeper that part of the land is, the further apart they are. So this one here is a 250 and this is a 200 down here. That's flatter. So the further apart they are, the flatter it is. The closer they are, the steeper that land is. And also just paying attention to the keys. So we've got the swamp is over here, the lakes are there, the unsealed roads are along here, sealed roads are all the red lines. Height in meters, we've given you that. Built up areas, railway. So always have a look at that. One thing that is not on this key, but you will see it a bit on maps, and it's something just to keep an eye out for sometimes, is the little triangle. So the little triangle that you can see here at Mount Erin, all right, that is referred to as a trig station, and that is the highest point on a map. So Mount Erin, 334 meters, is the highest point on this map. So we're going to break down scale and distance. So using the scale, using the information that we've been provided. So the first thing we need to have a look at is the scale here. So 1 centimeter equals 500 meters. Now each of these boxes conveniently is 1 centimeter in width, so that makes our life easy. When we're doing scale and distance, we literally just grab our ruler and we measure the distance. So we're going to do A to D. We grab our ruler, we pop it along there. 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't have my ruler in explaining this, but say it's 9 centimeters. 9 centimeters. We've got here 1 centimeter equals 500 meters, so we just go 900 times 500 meters, and that's going to be 4,500 meters. Okay, now we might ask you to convert that into kilometers. So there are 1,000 kilometers in, 1,000 meters in a kilometer. So that would be 4.5 kilometers. So make sure you look at the question. What are we asking you to convert it into? It's really important as well that you make sure that you do put in the unit of measurement, because sometimes teachers might be a bit slack and not give you the mark unless you've got the unit of measurement. The other thing that you might see is you might see a scale that's done as a ratio. All right, 1 centimeter, this means 1 centimeter is equal to 250,000 centimeters. Okay, do your maths the same way. Let's pretend that that was a 10 centimeter line. So we've got numbers that I can work with in my head. So that equals 10 centimeters in real life, on the map, equals 250,000 centimeters. So 10 times 250,000, so 250,000, and we add another 0 because we're timesing it by 10. So that distance, if it's 10 centimeters, is this far. Now, if we ask you to convert that into kilometers, the easiest way to do that is to figure out how many centimeters are in a kilometer. So we know that there are 100 centimeters in a meter. We know that there are 1,000 meters in a kilometer. All right, so all up, that is 5 zeros. So just jump your decimal point. 1, 2, 3, 4, 5. So that distance, according to this kind of scale, would be 25 kilometers. So if we asked you to put that into meters, you would have just taken two jumps. All right, and it's 25,000 meters. Okay, so this, when we give it to you like that, that's what we're looking at. So all we want you to do is measure the line and times it by the scale that we've provided you. The next one is direction and bearings. So we might ask you what direction a point is to or from a point, and we might ask you the bearing. So the first thing we need to always remember is north, south, east, west. However it is that you remember that. Never eat sour worms, never eat soggy wheat bix. There are a multitude of ways that you can remember that. We then can put in our next points. So northeast, southeast, southwest, and northwest. So we look at that. The final point that we pop in for a 16-point compass to make it just that little bit more accurate the midpoints here. Now, north, east, south, and west trump northeast, southeast, southwest, and northwest. So when we do it, we just look at what is the closest to it. So north and northeast. North is the most important, and then we look at northeast. Here we've got east and northeast, it's in between. East is more important. Okay, east and southeast in the middle there. East again is more important, so we mention it first. South and southeast. South is more important. South and southwest. West, southwest. West, northwest, and north, northwest. Okay, so that is your 16-point compass. So what we might do is we might pop a line here, and we might say, what is the distance of A to G? All right, it's really important that you read which word we wrote, because A to G means we start at A and we head to G. A from G means that we would start at G and we would head down to A. So if I say, what is the distance of A to G? On an exam, you're allowed to write all over it. All right, draw a compass. All right, draw your actual compass. So if we looked at that, the distance of A to G would be a northeasterly distance. Okay, so it's literally just what direction are you going to point in. As I said, draw yourself a compass. Make your life a lot easier. When we do bearings, you've got to remember that a compass is a circle. All right, so this is 360 degrees. All right, that makes north 0. It makes east 90 degrees, 180 degrees, etc. So when I ask you for the bearing, it's the same thing as the direction. All we're doing is we are adding the degrees that it is. So if we went D to H, all right, D to H, and you can use an actual compass, piece of equipment to help you with questions like this. But D to H is going to be just shy of 90 degrees. So you might say it's about 70 degrees, 75 degrees. Like I said, I don't have any tools with me at the moment, but you would say that it is, say, 75 degrees east, northeast. All right, so that's what we're talking about when we're talking about bearings. Direction is just the compass. Bearing, so this is just the compass, and bearings is the degrees that are associated with that compass. Okay. The next thing that we would look for if we're looking at topographic skills, and again I'm working with the ones that are mentioned on your assessment notification for year 10, is how to draw a transect. Transect is really, really simple. If I were to draw a line from, let's go point F, let's go H through to E, all right, and I said, what is the transect of E to H? All right, what we would do first of all is we would note, we'd maybe drop a piece of paper straight down here. All right, and every time there was a contour line, I'd do this straight down. Ooh, maybe a bit neater than what I've done. And what we've got here is we're going up in 50s. The lowest point on that line is going to be this one here, 200. So we might start at 200 and then we go 250, 300, 350, 400. Okay, so we know E is between here 200 and 250, so we might say E drops down to here, and at that point we've got a lake. All right, we then drop this one down, and that is a 200 down here. Drop this one down as 150. Whoops, we went down to here. 150, we're going to drop down to here. This one is a 200, so I'm marking it here. 250, so we're going up a hill now. 300, 350, 400. All right, and what we do there is we then mark what we're finding as we go along. So as we go along on here, we've got a lake. We might find along the line that we've got some railway tracks on here. We've got a station on this one. Here we've got a built up area along here. All right, so when we pull it all away and we look at the way that the land is here, we now have a transect. So the idea is we've drawn a cross section, which is the graph, and the transect is what have we found along the way of that. So we found a built section. I'm just going to rub that out for a moment. All right, so we've got something that kind of looks like that. We've got a lake. We've got some railway tracks. Okay, we've got a built-up area. All right, that's a transect. So you might say what can be found at point F, and then when we look at our transect, we can say, oh, okay, it's a built-up area. So being able to place this on top of that to show us what's happening on that map. So it might be a little map. Other than that, they're the main skills that are associated with this. Oh, I haven't done grid and area reference, have I? All right. So I'm going to now do grid and area reference. So we'll do grid and area reference now really quickly because I just realized I haven't gone over that again. Grid and area reference. This should be a really basic revision from year 7 for you all. The idea with grid and area reference is grid is a 4-digit number, is a 6-digit number. Area reference is a 4-digit number. If we are going to find anything with grid and area reference, let's do D first. Find the area first. As I said, you do the eastings first because alphabetically they're correct. And it's always in the bottom left-hand corner that you're finding your numbers from. So we go straight down and we say it's 41, and we go straight across and it's 53. So that's the area reference of box D. If we needed to get specific with box D, we would say it is 41.3, only you don't put the decimal point in, and we would go across and we would say it is 53.7, but again, you don't put the decimal place in. So I'll do A as another example. We would say it is 3250 as the area reference, AR, and the grid reference, which is a 6-digit number, with no decimal places in it. So we would say the grid reference is 32.5 and 54. So again, no decimal places in there. If it's on a line and we ask you for the grid reference of it, All right, you have to put a 0 in. So the grid reference of this one here, we would drop down and we would say it's 37.0 because it's on the line. And then we would go across and we would say it is 50.5 without the decimal point. So it's really important that you note that. Again, if it's on the line, it's from the bottom left hand corner. So if you're then drawing that box like that, this line here would be associated with 38.50. Okay, so hopefully that jogs your memory on how to do grid and area reference.